Right, sige, let's start. Habol na lang yung iba. So, class, our discussion this morning will focus on Kirchhoffs laws. Okay? So, yung outline will be the following. So, una is, what are Kirchhoffs laws? Ano ba yung nasabi natin na Kirchhoff law? Then, before we discuss yung mga laws na yon, okay, we'll be talking about the types of current law. Okay? Gagamitin natin mamaya to solve problems relating to circuits. Then the two Kirchhoffs laws, KCL and KVL equations. And then lastly is to solve problems using Kirchhoff law. What are Kirchhoffs? Sabi dito, Kirchhoff's law quantify how current flows through a circuit and then how voltage varies around a loop in a circuit. So may dalawa. How current flows through a circuit first, and then second is how voltage varies around a loop in a circuit. Okay. So before we move into the two laws of Kirchhoff, okay, we still have to establish the types of current. Okay, so depending on our type of current used in the analysis will actually affect our solving or solution for the problem. Okay, so we have two types of current. We have conventional current here, okay, and we have electron current, this one. Sabi dito, conventional current assumes that current flows out of the positive terminal of the source through the circuit and into the negative terminal. What does this mean? So conventional current means na yung current actually starts on the positive terminal of our battery. Okay, so from here, current will flow through the circuit and then goes back to the negative terminal of our. In this case, the flow is clockwise direction. Okay, that's for conventional current. Well, for electron current, okay, it is actually what happens where electrons flow out of the negative terminal of the source through the circuit and into the positive terminal of the source. This means that electrons, what actually happens, electrons, okay, since that this is called electrons, the negatively charged particles, so marapat lang na dito siya magsimula. The negative terminal of our battery, okay, and then it flows through our circuit, then back to the positive terminal of. Ito yung talagang nangyayari in actual. Okay, so the flow is counterclockwise in this. So this is the electron current. Now mamaya gagamitin natin class, okay, on our problem solving activities, itong electron current. So we always start our analysis from the negative terminal of our battery, then okay, towards the positive terminal of our battery. Okay, so remember this electron current. It starts from the negative, then goes back to the positive terminal of our battery. So here is the first Kirchhoff law. We call it the KCL. KCL, or the Kirchhoff's current law. It states that the current flowing into a node or a junction must be equal to the current flowing out of it. We have an example here. So using KCL, determine the value of I, circuit segment below. So this is the circuit segment. In this case, we have 5 wires. Okay. And then the wires have currents. Okay, this is 5 amperes, I, 3 amperes, 4 amperes, and 2 amperes. As you can notice, there's also a direction in the arrow. Okay, so this point here, class, where the 5 wires actually meet, okay, this is what we call the node or the junction. Okay, so the current flowing into the node must be equal to the current flowing out of it. Flowing out of the node, the currents that are flowing out of the node, we have the 3 amperes, the 4 amperes, and the 2 amperes. Current flowing into the node, we have 5 amperes and this unknown value, I. Sabi dito, using KCL, current entering the node is equal to current leaving the node. Okay, so 5 amperes plus I must be equal to 3 amperes plus 4 amperes plus 2 amperes. So, okay, 5 amperes, ilipat natin, magiging negative, and then we add 3 plus 4 plus 2, that's 9. Actually get the current value of I, which is 4 amperes. That's basically class yung Kirchhoffs current law. Now we have here a familiar drawing. Okay, we have the supply 100 volts, and then 25 ohms, 20 ohms, 10 ohms. Okay, and designated by the currents I3, I2, I1, and total current. If you compare this one to the previous slide, okay, we can say that this part over here, this is our node or junction. This is where the 4 wires meet. This wire, 1, 2, 3, and 4. Dito sila nagtagpo. We call this our node or junction. Okay? So to calculate I1, okay, based on our discussion on Ohm's law, current is equal to voltage divided by resistance. So 100 divided by 25, that would be 4 amperes. Ito naman, I2, 100 divided by 20, that would be 5 amperes. And this one, 100 divided by 10, I3 will be 10 amperes. 10 plus 5 plus 4, okay, we actually get the total current, okay, flowing into the node, which is, okay, 19 amperes. This is basically yung Kirchhoff's current law. Okay, we were able to solve the total current by adding the currents in each parallel na branch. Okay? Now, through a simulation, ganito naman yung forma nito. $100 volts per amperes, involved natin kanina, 5 amperes, 10 amperes. And this is the total current, 19 amperes, which we found out using KCL. The last time, okay, we have actually discussed how to solve the total resistance, the 25 ohms, 20 ohms, and 10 ohms. Okay, and we found out that this is the way to solve this one. The total resistance for this one. Okay, so we have actually learned during the parallel circuits discussion that the total resistance can be solved using this formula. 1 over RT is equal to 1 over R1 plus 1 over R2 plus 1 over R3. Okay, since we have 3 resistors, 25, 20, and 10 ohms. Then we get the LCD. Then 100 divided by 25 times 1, 4. 100 divided by 20 times 1, 5. Then follows. So nakuha natin 19 over 100. 1 over RT, 19 over 100. Okay, so we get the reciprocal. Pagpalitin natin yung numerator at denominator. So RT over 1 equal to 100 over 19 ohms or 5.26 ohms. What does this mean? Okay, this just means, okay, so this just means that, okay, these 3 resistances, okay, pag pinagsama natin yan, this is just equivalent to 5.26 ohms. You can see here, we calculate the total current using this total resistance, 100 volts divided by 5.26, we will arrive on the same total current na 19 amperes. Okay? So this circuit, ito, composed of 1 supply and 3 resistors, is just equivalent to this 1 supply and 1 resistor. That's why this is called the total resistance, or equivalent resistance of these 3 resistors connected in parallel. Okay, so what we actually discussed kanina is there are 2 ways to solve the total current. Either we use the KCL, okay, calculating the individual currents, 100 divided by 25, 4, 25 amperes, so 10 amperes. and then adding them up, totaling to 19 amperes. Or the other way is to solve for the total resistance. Then after that, 100 divided by the total resistance, that would be the total current. Pwede din ganun. Okay? So that is for KCL, for the Kirchhoffs current law. Then current entering a node is equal to the current leaving the node. Now we now move on to Kirchhoffs voltage law. The sabi dito states that in any complete loop within a circuit, the sum of all voltages across components which supply electrical energy, such as cells or generators, must equal to the sum of all voltages across the other components in the same loop. Ibig niyang sabihin nito, class, there is actually a voltage supplier and a voltage consumer. Voltage suppliers and voltage consumers. So typically, yung mga suppliers natin are cells or generators. I-add natin yung lahat ng supplier and then i-add natin yung voltage consumed, okay, by the other component. Kailangan mag-equal. In this case, using KVL, okay, so using the electron flow of current. So again, coming from here, the flow of current will be from the negative pabalik sa positive ng battery. So this is counterclockwise. In this case, kung titingnan natin, okay, so current will flow and then it will hit the positive of our battery first. So positive 6 volts will hit the negative, so negative 2 volts, then negative voltage across 2. So that is why ganito yan. 6 minus 2 volts minus voltage across 2 is equal to 0. So again, positive 6 minus 2 volts, then minus voltage dito. If we transfer this to the other side, so magiging positive, 6 minus 2 will be positive 4. So this is the voltage across the 2 ohm resistor. Okay, so 4 plus 2, voltage consumer is 6 volts, then voltage producer is 6 volts. Kailangan mag-equal. Yan ang yung ibig sabihin ng Kirchhoffs voltage law. So again, we have a familiar circuit here. This is in your quiz last time. Okay, so we have first and then 3 resistors. Okay, we will no longer solve this one. Ang gagawin natin, we'll just look at the simulation. You can see, okay, we have here 100 volts and then the total current is 1.80 here. Here is circuit, okay, same current will flow all throughout. Or constant na current. Okay, so 1.82 amperes, 1.82, 1.80 all throughout. Now for the voltage drop, papansin natin that this is 45.5, 36.4, and 18.2. Now if we add the voltage drops using KVL, V1 plus V2 plus V3, this will actually total to 100 volts. Voltage consumers is equal to the voltage supplied. Yan yung KVL. Okay, so another way to solve this one, class, to solve for the total resistance, this is series, i-add lang natin 10 plus 20 plus 25. That will be 55 ohm. 100 divided by 55, that is the 1.82 amperes. So pwede din na ganun. Okay? Then we have this example for Kirchhoffs voltage law. Here is to use Kirchhoffs voltage law to find VA and VB. So, hanapin natin yung value ng VA, hanapin natin yung value na starting by working out VA using the loop, which makes up the left-hand side. We have 2 circuits, ito. We have this first loop using electron flow, so from negative to counterclockwise, kaya itong yellow-green. This is the left side loop, and this is the right side loop. Sabi dito, at left side loop, okay, then negative, then matatamaan niya yung positive ng battery. So positive 9 volts, plus 9 volts, then minus 1 volt, minus 1 volt, then minus VA, then minus 2 volts is equal to 0. Then we use electron flow. So to solve for VA, transfer natin sa kabila, magiging positive. 9 minus 1 minus 2, that is positive 6. So that is the value of VA. Now at the right side loop, the last example, this one, we have here if V, okay, is equal to 12 volts. So this one lang matatamaan yung 12 plus VA. So this one, voltage across R1 plus VA is 6 volts. Then minus 2, minus 2 volts, 6 volts. Then minus, and R2, VB, this one is twice, then minus the value of R3. So this means na kung R3 is 2 ohms, so VA is 4 ohms. So 6 minus 2 ay 4 ohms, minus 3 is positive 1. Then itong negative VB, lipat natin sa kabila. What's now the value of the voltage? So VB is equal to R3, 1 volt. Ano din yung voltage drop? This is how we use Kirchhoffs Law to establish an electron solve for the unknown. So we hit this part over here first. So positive V, this one. And we all know that resistances talaga. Combine muna natin to. So R2 series with R3, R2 series with R3, tapos parallel with R4. So isang voltahe lang ito muna. Plus V minus V R2 series with R3 parallel with R4 minus VR1 is equal to 0. So this is 12. VR1 is 6 volts. Lipat natin sa kabila, magiging positive. 12 minus 6 will be positive 6 volts. That is the value of this one. So this voltage over here. Now, from parallel circuits, we know na voltage across parallel is actually equal. So VR4, 6 volts, is equal to dito, R2, okay, in series with R3. And sabi natin last time, resistances is directly proportional to voltage. When we increase the resistance, we also increase the voltage. In this case, we have this equation. And then, okay, sabi dun sa problem, R2 is equal to 2 times R3. Substitute lang natin dito. Kung mapapalitan ko ng 2R3, mag-cancel out yung R3. And then, alam natin that the voltage of R3 plus yung voltage ng R2 dapat mag-equal sa 6 volts since this is parallel. Okay, so nakuha natin kanina ito. So, VR3, so yung VR2 is actually equal to 6 minus VR3. Ano man yung voltage ng R3, taltas natin yun sa 6 volts. Yan yung value ng VR2. Okay? So, cross multiply this one. So, 2 VR3 plus 6 minus VR3. And then, lipat natin ito sa kabila, magiging positive. So, naging 3 VR3 is equal to 6. So, VR3 is equal to 2 volts. That would be all for this video about Kirchhoffs laws. If you have any questions, just comment down below or send a message in our GC.